So in the transition from sort of the fed state to the fasted state, you go from, say, and this is from Cahill's data, up to about 24 hours. If you have a relatively high carbohydrate diet, you're going to have enough glycogen to take. So glycogen is chains of glucose that is in your liver. So your liver just takes the glycogen, chops off the glucose, and sends it out into the blood. And so you're still metabolizing glucose. Fat is a triglyceride, and it's totally different. So it's 3 fatty acid chains with a glycerol. So the glycerol gets converted into glucose, but your body mostly metabolizes the fatty acid chains, not glucose. It's a totally different source of energy. It's sort of like, you know, electricity versus gas. They're both forms of energy, but they're totally different. And it's the same with fat and glucose. In between when fat metabolism ramps up, there's this period from about, say, 24 to 30 hours where you're actually breaking down some protein in order to provide glucose because your fat metabolism hasn't ramped up sufficiently yet. And that's where people kept saying, well, look, you're burning muscle, you're burning muscle. It's like, no, you're burning protein, which is not the same as muscle. And this is very important because your body has excess, or an obese person has excess, not just fat, but excess protein as well, because you got the skin and you got the connective tissue and all that structural stuff, which is not fat. And this is one of the reasons, and this is a clinical observation, so I don't have any data to back it up. But we've treated, you know, thousands of people, and some have lost hundreds of pounds, and we've not referred anybody for skin removal surgery because we tend to use a lot of fasting. And during fasting, you actually want that period of burning this excess protein, which is connective tissue and skin, because your body, remember, replenishes skin every few days. Skin cells get replaced. But if you're not eating, your body doesn't want to replace those skin cells. So it's going to metabolize them. So this is the same thing you see in prisoners of war from Japan. There's no excess skin flapping off of them, right? Even if they lost 50, 80 pounds, because they've metabolized that protein for energy.
When you read the history of the research, we've always known that about 25, 30, 35% of the excess weight is lean tissue to accommodate, carry the fat tissue. So something has to decide whether the excess calories are going to go to fat tissue or lean tissue, which tells you right there that the accumulation of both has got to be hormonally regulated, right? Because it's not just, if you're assuming that the fat tissue got fat because you just dumped excess calories into it, then what prompted the lean tissue to be built up along with it?
The recent data from some of the intermittent fasting studies show that you don't get an increase in muscle loss. It tends to actually be preserved better. And again, one of the things that we know is that when you don't eat, there's a predictable sort of change in hormones. That is, not only do you see insulin fall, but you get this other hormones that go up. And one of them is growth hormone. So growth hormone is going to bump up, which is going to help you preserve lean tissue, because in a state of growth hormone deficiency, for example, we know in men that you can replace it and, you know, you'll get more muscle growth and all this sort of stuff. So that increase in growth hormone may help preserve that sort of muscle while sort of still losing all the skin and connective tissue that you want to.